Welcome back. In this video, we'll be learning about encoders. So, what is an encoder? So, encoder is basically similar to a multiplexer. It is also a digital combinational circuit which converts multiple input signals into a binary code, and it will typically generate more than one output. In multiplexer, we only had one output, but in encoder, we will have the outputs based on the input lines. So if there are two input lines, then 2 to the power of 2, we have 4 inputs, and then we have 2 outputs. Here we don't have any select line. If n is 3, then we have 8 input lines and 3 output lines. If n is 4, we have 2 to the power of 4, 16 input lines and 4 output lines. So first, 4 is to n, so 4 means 2 to the power of 2, so 2 output lines. So 4 is to 2, this is the diagram of 4 is to 2 encoder. Y0, Y1, Y2, Y3, A1 and A2 are the outputs. So this is a truth table. So in truth table, we first enable Y0. So Y0 will be 1. Then we'll select Y1. So 0, 0, 1, 0. Then we'll take Y2, 0, 1, 0, 0. Then we'll take Y3, 1, 0, 0. So this is for 0, equivalent of 0. So this is the output will be A1 and A0 will be 0, 0. This is for 1, so the output A1 and A0 will be 0, 1. This is for 2, the output A1 and A0 will be 1, 0. This is for 3, the output A1 and A0 will be 1, 1. So how this expression is written? So basically this expression is written by observing this column. So if you observe this column, so here, you know, when there is A1 is 1, so A1 is 1 in these two cases. For what two cases? For Y2 and Y3. So this is the equation for A1. I hope you got this point. A1, just observe A1, where A1 is 1. So A1 is 1 in these two cases, for Y2 and for Y3. So that's why Y3 and Y3 or Y2. That's how this equation is written. Whereas for A0, if you observe A0, where A0 is 1, here and here. So A0 is 1 when Y1 is 1. So Y1 is written here. Then A0 is 1 here when Y3 is 1. So Y3 is written here. So Y3 and Y1. So Y3 and Y1. So Y1 is 1 and Y3 is 1. So the OR of these two. So that's how these two equations are written. Now coming back to the circuit diagram. So for A1 it will be Y3 or Y2, and A0 will be Y3 or Y1. So this is the circuit diagram. Similarly, we have 8:3 encoder, and we will follow the same rule for 8:3 encoder as well. In a 8:3 encoder, we have Y0, Y1, Y2, Y3, Y4 up to Y7, and outputs A0, A1, A2. So first we take Y0, we take Y1, we take Y2, Y3, Y4, Y5, Y6 and Y7. So for A2, the expression will be, we have to notice where the A2 is 1. So A2 is 1 in these 4 cases, when Y4, Y5, Y6 and Y7 is taken. So Y4, Y5, Y6, Y7. Similarly, when A1 is 1 in these two and in these two, when Y2 is taken, Y3 is taken, Y6, Y7, Y2, Y3, Y6, Y7. Similarly for A0. So this is the expression for 8:3 encoder.